So next reactive intermediate is carbene. So after carbocation, carbanion, free radical, next most is carbene. So first we need to discuss about structure of carbene. So carbene is a divalent carbon intermediate. It is a divalent carbon intermediate having two non-bonding electrons. Carbene is a divalent carbon intermediate having two non-bonding electrons. So they having valency 2 and they carry two non-bonding electrons. So you can write a carbene like this, carbon bearing two hydrogens and here two electrons are present. So we can say them as a biradical even. So it is an example of biradical, carbon biradical. So two electrons are present on carbon. They are carbon electrons only, but they are not participating in bonding. So they are called carbenes. Okay. So generally carbenes are classified into two types. So first one is singlet carbene, second one is triplet carbene. Carbenes are classified into two types, singlet carbene, next is triplet carbene. How many types of carbenes are there? Two types, singlet as well as triplet. First, singlet carbene. What is a singlet carbene? Singlet carbene is nothing but it is a same divalent carbon, but see these two electrons are available in the form of a lone pair. They are present only in one orbital. So valence is 2, but these two electrons we don't know whether it is a free electrons completely or they may be a lone pair electron. So in case of a singlet carbene, it is a valency 2, but these two electrons are available only in one orbital in the form of a opposite spin electrons. Means one is clockwise, other is anti-clockwise. So this is in the form of lone pair. So we can write like this. Divalent carbon intermediate having two non-bonding electrons. In the form of lone pair. So they exist in the form of lone pair. Divalent carbon intermediate having two non-bonding electrons in the form of lone pair. They exist in lone pair, which means carbon having how many bonds? Two bonds. Listen carefully. From here onwards, be careful. Carbene, nitrene, benzene. If you know these three, approximately pericyclic is very easy for you. These three concepts, some name reactions are there. Rearrangements also belongs to carbene, nitrene, which may helps in molecular rearrangements as well as it may also helps in pericycle. Even photochemistry also, carbene, nitrene, benzenes are most important. Now here see one orbital is there which is a lone pair and other orbital is there which is completely empty p orbital. Now two electrons are exist in opposite spin, it is in the form of a lone pair. So this is nothing but a singlet carbene. So in singlet carbene you can write like this, two electrons with a opposite spin, you can write like this. Carbon carry two electrons with an opposite spin is nothing but a singlet carbene. And what is the hybridization of singlet carbene? Hybridization is, can I write sp2? So two bond pairs and one lone pair. Two bond pairs, one lone pair is nothing but sp2. 1, 2, 3. Okay, then what about C? This is completely angular shape. It is complete angular. And what about bond angle? Bond angle is 103 degrees. This angle is many times asked in exam. Angle is expected for your exam. V shape or angular shape and bond angle is 103. Suppose if carbon carry two hydrogens and here what I am writing now? I am writing lone pair like this. Can I write like this? Lone pair. So what kind of spins they have? Opposite spin. Now here what is an angle expected here now? 103. Suppose if these hydrogens are replaced by chlorine, now angle is 100 degrees. If chlorines are replaced by bromine, Okay, now angle is 104. If bromines are replaced by methyl, okay, when bromines are replaced by methyl, angle is little bit more increases, that is 111 degrees, which means angle is maybe little bit increases, that depends upon the size of carbon substitutions. It may be a lighter groups or it may be little heavier, mostly angle is ranges in between 103 to 110 only. Okay. Now finally we can say multiplicity formula. What is multiplicity formula is saying? Multiplicity, spin multiplicity is equal to 2s plus 1. What is s? Spin of electron. So what is the spin of electrons which are not involving in bonding? One is clockwise, other is anti-clockwise. Can I substitute like this? 2 into, is it plus of or not? Plus of, minus of. One is clockwise, plus of, minus, this is minus of, is equal to plus 1. Now finally see, 2 into 0 or not? So 2 into 0 and this is 0 plus 1. 0 plus 1, 1 means what? 1 means it is singlet. That is the structure of singlet carbon. So right now remember, if I say the word singlet, 2 electrons are in opposite spin. And singlet carbon is a, remember, singlet carbon is a Lewis acid. This question also they asked. It is electron deficient, carbons are electron deficient, right? Why carbons are electron deficient? Why? Because short of electrons. How many electrons they have? 1, 2, 3, 4, 5, 6 only. Short of octet, they are also electron deficient. Especially singlet carbon is a Lewis acid due to presence of empty p orbital. So now these two, if 2 electrons on carbon, if I write in the form of lone pair, means they carry one empty orbital. Okay. So this is called singlet carbon. Triplet carbon. First try to understand key concept. What is the key point in this one? Carbon carry 2 bonds and 2 electrons. 2 bonds and 2 electrons are there. Now how these 2 electrons are orienting? Based on that, carbons are 2 types. Not on based on these bonds, it is based on these 2 electrons. If 2 electrons are present on one atomic orbital, it is singlet with opposite spins. Opposite spins. If 2 electrons are present on 2 adjacent orbitals, that is called triplet with same spin. Right now they have opposite spin, triplet having a same spin. Now we can write like this. Divalent carbon intermediate having 2 non-bonding electrons, 2 non-bonding electrons in the form of free electrons, in the form of free electrons. They are not in lone pair. Now see the differ in their statement. Here 2 electrons in the form of lone pair, 2 electrons exist in free electron. Now it is a pure biradical. It is also biradical, but they exist in the form of a lone pair. So in the form of a free electron. So can I write like this? Carbon, here hydrogen is there. Now here one orbital is present. Okay, so this is one of the orbital, and here one more orbital I am writing like this. Now here see, this carbon nitrogen bond is present. Now later on, here this is one of the orbital, p orbital, here one electron, here one more electron. Okay, this you can also write like this. Carbon carry how many hydrogens? 2 hydrogens. Carbon carry 2 hydrogens, you can write like this. Don't write 2 electrons adjacent to each other with same spin. Try to write 2 electrons freely with the same spin. Same spin nothing but clockwise, clockwise or anti-clockwise, anti-clockwise. Now what is the hybridization over here? sp, be careful, it is not sp2. This hybridization question is also most important for carbons. Only one bond pair, there is no lone pair. So in triplet carbon there is no lone pair, that's why 2 bond pairs sp. Now what about geometry? So geometry is not linear, so it is angular. Generally what is the geometry of a molecule carry sp hybridization? Linear, but right now it is angular. And what about bond angle? Bond angle is very very important, 136. Bond angle is 136 here. Okay. Now if you apply multiplicity, multiplicity is equal to 2s plus 1. Now 2 electrons with same spin or not? 2 into, can I write plus of or not? Plus of plus 1, and finally see 2 plus 1, finally this is 3. That's why we are saying it is a triplet. This is triplet. Here also angle is get affected by substitutions. So but if hydrogens are present, what is the common angle? 136. If hydrogens are present, what is the common angle? 103. So it is initiated angles later on by the size of the atoms or molecules and electronegativity. So little bit variation is observed. But it is not 180, be careful. sp hybridized molecule should carry linear. It is a angular. sp hybridized molecule having a bond angle of 180, but it is 136. Clear? Next, you write some points. Carbons are electrophilic in nature. Carbons are electrophilic in nature, especially they are neutral electrophiles. They are not positive electrophiles, they are neutral electrophiles. Carbons are electrophilic in nature, so you can write it as neutral electrophiles. And especially singlet carbon is Lewis acid. What about triplet carbon? Triplet carbon is not a Lewis acid. Only singlet carbon is a Lewis acid. Why it is Lewis acid? Due to presence of empty p orbital. Due to presence of empty p orbital, singlet carbon behaves as a Lewis acid. Is there electrophiles? Is both are electrophiles? Yes, both are electrophiles. Okay, both are electrophiles, but only singlet carbon is a Lewis acid, but not triplet carbon. Why? Because due to presence of empty cavity, empty p orbital is there, that will attract the lone pair of electrons present in a Lewis base. Okay, but both are electrophiles, both are neutral electrophiles. So we can say carbons are formally neutral. Formally neutral charged species. Carbons are neutral charged species. Formally neutral charged species. Is there paramagnetic or diamagnetic? Singlet carbon is, you can guess, it is diamagnetic. Singlet carbon is diamagnetic, but triplet carbon is paramagnetic. Why they are paramagnetic? Two electrons present in two different orbitals. Now they don't have opposite spin in case of triplet. Triplet, two free electrons are present, that's why it is paramagnetic, but singlet is diamagnetic in nature. Theoretical questions also you can expect in your exam. Sometimes they will ask direct regarding a carbene or singlet carbene, which among the following statement is correct regarding carbene. They will mention as a carbene, but in options they will mention singlet carbene statement, triplet carbene statement, or carbenes which are related to common property. Okay, so take one question regarding this. Which of the following hybridization does not exist for carbenes? Does not exist for carbenes. SP, SP2, option C, SP3, all. Which hybridization does not exist for carbenes? Which one? That is SP3. SP3 hybridization does not exist for carbene. The bond angle of singlet carbene is, they are asked questions. Even if you know, you just write down. That is 120, 109 degrees, 28 minutes, option C. 103, option D. 180. Bond angle of singlet carbene, that is 103. If they mention only singlet carbene, means hydrogens. So don't confuse, it is not methyl groups attaches to carbon, carbon attaches to only hydrogens, that is 103. So what is hybridization for singlet carbene? sp2, triplet is sp. These 2 points are common for nitrine. If you know carbene clearly, you can understand nitrine very easily. Same nitrine, singlet nitrine having sp2, triplet nitrine having sp. But in case of singlet and triplet nitrine, both cases having linear geometry. Why? Because it is a monovalent, but right now it is a divalent. That is the only one difference. So in case of nitrine, 2 lone pairs are present. Okay. In case of carbene, only 1 lone pair is present. In case of triplet carbene, 2 independent free electrons are present. In case of triplet carbene, 2 independent free electrons. In case of triplet nitrine, 1 lone pair and 2 independent free electrons. So you will understand clearly once if you enter into nitrine concept. Right now you focus only on carbene. Carbenes are 2 types, singlet and triplet. So singlet carbene having 2 opposite spin electrons, triplet carbene having 2 same spin electrons with a valency 2. Bond angle is 103, 136, sp2 and sp. That points are sufficient. Right, generations. Generations of carbene. How to generate a carbene? Okay, so first I will start with a cyclopropane. Cyclopropane. Photolysis of cyclopropane always leads to form a carbene. See, I am taking a aromatic ring and this is cyclopropane, right? Cyclopropane on photolysis. Now try to remove that carbene which is having a unstable carbene should be removed out. Now see, here I am writing a clockwise. what kind of bond present over here now? Sigma bond or not? Sigma bond between these two. Here it is a clockwise and here it is anti-clockwise. Now it is anti-clockwise means it is clockwise. Now it is anti-clockwise. Okay. Cyclopropane on photolysis. These two radicals are combined together and forms a double bond. This radical after breaking this bond I am saying. I am breaking like this. If I break here, this radical left on this carbon, this radical left on this carbon. Now these two radicals left on this carbon. Now see, this carbon carry how many electrons now? 2 electrons are available. What is this? Carbon. Now what about here? Carbon-carbon double bond formation will take place. Finally you will get this carbon. Okay. Now suppose if dissimilar substitutions are present, what kind of carbon is going to be observed? So where we need to break, that is most important. Where we need to break? Try to break such a way that you should get an unstable carbon. Now can I break here? Break this and this. If I break here, this carbon carry 2 hydrogens. This radical forms a double bond. After getting double bond, this carbon carry CH2 or not? CH2, 2 electrons. Okay. Now try to give the answer, don't write, just listen. I am giving a 3-membered ring and this is CH3. Now photolysis, what is the answer? Where you will break? Can I break here? Break this side. So if I break here, double bond and this is CH3 and finally see this carbon carry how many electrons? 2 electrons. It is a way of generating by using a cyclopropane. So we can also generate by using a epoxide. Epoxides on photolysis, same answer. You know epoxide? What is epoxide? Oxirane. This is oxirane. Epoxides on photolysis always break this bond. Now this carbon oxygen forms a carbon oxygen double bond and can I write CH2 with 2 electrons or not? CH2 with 2 electrons. Suppose if unsymmetric substitutions are present, unsymmetric substitutions, can I break like this? Break from that side where you will get unstable carbon. If you remove unstable carbon, you will get a neutral molecule in a stable manner. Okay, so here you may get like this, carbon oxygen double bond and here hydrogen. Can I remove this carbon in the form of CH2? Right? Suppose if I write two unsymmetric substitutions. Now here see I am writing CH3 and I would like to generate under photochemical. Which side I would like to break? Left side or right side? Right side. Why? Because radical methyl unstable. Radical with benzene more stable. Unstable side we need to break. If I break right side, will you get like this or not? Double bond O and CH3 connected to CH or not? CH3 connected to carbon with 1 hydrogen. Now this carbon I am writing 2 radicals. That is the answer. Now one more, by using a bicyclic compound. By using bicyclic compound, you can have a tendency to generate a carbons. Okay. Now see, this is a bicyclic compound. Now it is connected to carbon with 2 alkoxy groups, OCH3 and here one more OCH3. Here I am writing double bond, double bond. Now this is on photolysis. Now break this bond and this bond. What happens? If I break like this. If I break here, now you will get 1 radical. And if I break here, you will get 1 radical. On this carbon, how many radicals you will get? On this carbon, will you get 2 radicals or not? So this is methoxy attaches to carbon. Next here also methoxy attaches to this carbon. Now this carbon carry how many radicals? Now here if you are breaking means this bond is connected to here. It is not connected to this one. It is connected to this carbon. If you break here, this carbon carry radical. So can I write 2 radicals? This is 2 radical. Now if you remove this, if I write this bicyclic compound clearly, will you get like this or not? Here you will get double bond and what is this? Radical and this is radical. Can I write like this? Is it clear? After getting these 2 radicals, now I am breaking this bond. If I break this bond, this radical get combined together and you will get a benzene or not? This radical double bond. This radical double bond. Already one more double bond is this. Okay. So cyclopropane on thermal decomposition or photochemical decomposition will give carbon. Epoxide on decomposition will give carbon. And one more bicyclic compounds with a proper substitutions that may also decompose carbon. It is actually photochemistry topic. There you will get many examples. So right now you take sample examples. Always try to remove carbon with 2 electrons such a way that it should be highly unstable. Highly unstable like that. Can I ask one question here? Now we are removing one carbon. Which carbon we are removing? In this one carbon is coming out. Carbons are two types, singlet and triplet. Now you get one question in your mind, I think so. Sir, you are removing one carbon. What kind of carbon is elutes out from the reaction? Try to see clearly. Clockwise, anti-clockwise. Singlet or triplet? While you are breaking, you will get a singlet. But after breaking, it will be settled down as a triplet. Why? Because singlet having one lone pair or not? One lone pair never involved in bonding. Lone pair is not a bond pair of electron. Actually what I am saying is this carbon carry two lone pairs. Here one lone pair is present and here one empty orbital. In this carbon any empty orbital is there? No. Then how it would be a singlet carbon? It is a triplet carbon. It looks like a singlet carbon, but actually it is a triplet carbon. So you won't get any singlet, you will get triplet only. Why? Because according to Hund's rule of maximum multiplicity, all degenerate orbitals should carry, see this is carbon, all degenerate orbitals should carry same spin or not. Suppose if I take sp3 hybridized carbon, 1, 2, 3, 4, okay, all electrons having same spin or not. So if carbon having tetravalency, if any carbon having tetravalency, its own electrons, carbon own electrons will participate in same spin or opposite spin. They will participate in same spin. Here we are writing opposite in direction, but actually they will participate in same spin with bonding with hydrogen. Suppose if I write CH4, here it is clockwise, anti-clockwise, clockwise, anti-clockwise, anti-clockwise, anti-clockwise. Clear? So finally your answer is always which carbon? Triplet carbon only. Don't generate singlet carbon. After generating triplet carbon, it will be assembled into a singlet carbon while participating in any chemical reaction. There is a choice is there. Triplet may be converted to singlet due to their de-excitation process. So this electron migrates from here to here means then you will get one empty orbital. That empty orbital is this one. Triplet converted to singlet. When triplet converted to singlet, there is a generation of a empty orbital. Is it clear? When you dissociate any cyclic molecule, what kind of carbon will be extracted out? Triplet. Don't say singlet. If it is breaks, spontaneously convert into triplet. It is impossible to trap in the form of a singlet. Why? Because singlet is a de-excited molecule, but triplet is a excited molecule. So in carbon always excited molecule will participate in reaction if it is a tetravalent. What is the valence of carbon? 4. Here 4 valence is there. If 4 valence is there, all electrons are in triplet state. Be careful with this statement. If I write 2 dots means it is triplet only. Sometimes I will participate in the form of singlet. What I am doing is on the time triplet is de-excitated and gives singlet, then I am introducing in that one. But every time remember, first is triplet only, later on singlet. Without triplet, impossible to create singlet. This one. Here you write radical. Over. So next is carbons are get generated by using, see, one most important molecule, diazomethane. From diazomethane we can generate. Carbons can be generated by using diazomethane. So what is diazomethane? Remember, this structure is very important. One name reaction will be there and rearrangement also there with respect to diazomethane. CH2, nitrogen, triple bond, and this carry positive charge, this carry negative. This is called diazomethane. Remember this molecule. If you know this molecule, one methylation reaction, one Grignard reaction, untested rearrangement, Wolff rearrangement, nearly 4 reactions will be in your hand. So if this negative charge migrate here and these electrons will migrate on nitrogen, so this is resonance stabilized isomer. CH2 carry double bond and here nitrogen carry double bond, and see what is this? N, and what is this? N minus N plus. You can write either this structure or this structure, but convenient structure is this one. It is also involved in pericyclic as a 1,3 dipolar cycloaddition. This negative ion attacks on one double bond and this negative ion attacks here. If this molecule involved in 1,3 dipolar cycloaddition in pericyclic reaction. Diazomethane. Carbon carry negative, terminal nitrogen carry negative charge. Internal nitrogen carry positive. So this skeleton they may also represent like this. They will write like this: CH2N2. CH2N2. CH2N2 if I given, you remember these structures of diazomethane. Okay. When diazomethane on photolysis, what happens? Try to break a bond between carbon and nitrogen. So then this carbon is eliminates in the form of a carbene and nitrogen is eliminates in the form of N2. Okay. So this structure you remember. Diazomethane on photolysis will give carbene. Okay. And one more, see, this is very important molecule, diazoketone. It is comes in Wolff rearrangement. Diazoketone. So this is RC double bond O. Next this O attaches to CH. Next here nitrogen triple bond will be there. This is plus and this is minus. Is it similar to this one or not? Both are same or not? Both are same. This and this both are same, but one of the hydrogen I replaced it with a acyl. Now this is on photolysis. Now what happens? N2 is removed out. When N2 is removed out, now RC double bond O, now carbon carry how many lone pairs here? One lone pair of electron or two independent electron. What is removed out? There is a loss of N2. This is called acyl carbene. What is this? Now this is a acyl group. Acyl group attaches to carbene. Say acyl carbene. Okay, this is called acyl carbene. Next, see here we can also use alkyl aceto, otherwise you can say acetic ester. Alkyl acetic ester. It is also one more process to generate a carbene. So alkyl means I can write like this: RO attaches to C double bond O, and here CH nitrogen triple bond plus, and this is minus. This is on photolysis. Can I make this? So simply can I break here or not? So if I break at this particular place, N2 is removed or not? In place of acyl group, right now I am giving a acid ester. If I use acid ester, can I get this? RC double bond O, double bond, and what is this? CH attaches to carbene. So this is called alkyl and it comes from acetic acid ester. So that's why it is called acetic ester. Alkyl acetic ester. Next we can also generate by ketene. You know ketene. What is ketene? Ketene is isomer which is produced in Wolff rearrangement. This is a ketene, not ketone. Ketene. Diazoketone to ketene. Preparation is called Wolff rearrangement. Diazoketone to ketene is wolf rearrangement. Now this is on photolysis. What happens? See, break this bond, and what happens? Carbon carry 2 electrons, and what is removed here? There is a loss of CO, carbon. What is this? Molecule name, ketene. If I write carbon here, alene. If I write nitrogen here, if I write nitrogen in this particular, you know isocyanates, NCO. Suppose here if I write nitrogen, isocyanate, that will comes in Hoffman rearrangement, Curtius, Larson and Smith rearrangement. Right now it is comes in Wolff rearrangement. That's why after react intermediates in your syllabus, definitely they will mention molecular rearrangements. Why? Because molecular rearrangements always depends on intermediates only. Suppose if you know carbocation, they will ask what are the molecular rearrangements, includes carbocation, then carbanion, then free radical. Okay, then go for carbene. Carbene rearrangements are, can you give some carbene rearrangements? Untested rearrangement, Wolff rearrangement. Nitrogen rearrangements are very high in number. Hoffman, Larson, Curtius, Smith rearrangement. Okay, so like that, if you know intermediates, some named reactions will be in your hands. You can guess what they will ask in your next step. Okay, take down ketene. These generations important for your reagents. In the same way, they are also very, very important for pericyclic reactions and interconversions, especially name reactions. Reactive intermediates are heart of reactions. Generally, don't expect straightforward question from intermediate. Okay, you can expect one molecular rearrangement. You can expect a name reaction. You can expect one interconversion. Otherwise, you can expect one starting reaction which includes a reactive intermediate. So very few questions you can expect from intermediates directly. Try to remember names. Names are very, very important. Next. Now see this. Now I am using a haloform. Haloform in alkali medium, also responsible to generate a carbene. You know, I am using a chloroform, CHCl3 in presence of sodium hydroxide. If chloroform reacted in presence of sodium hydroxide, there is a generation of dichlorocarbene. You know, Riemann-Tiemann reaction. This combination, remember. Chloroform in sodium hydroxide. We can also react a bromoform. Bromoform in sodium hydroxide. Bromoform in sodium hydroxide, you may get CBr2, 2 radical. Suppose minimum 1 hydrogen is required here. Here 1 hydrogen, now C, I am giving 2 bromines, 1 chlorine. Now whenever different halogens are given, what is the situation to remove halogen? Now here 3 similar kind. Right now I given 2 different kind. On that cases, try to remove hydrogen first. Remove less electronegative halogen. Don't remove high electronegative halogen. So now carbon carry. Can I write one bromine and one chlorine? Bromine and chlorine. Okay. Suppose if molecule carry CHClBr2. Sorry. Cl2Br, CHCl2Br, then what is the answer? Now if I use sodium hydroxide, tertiary butoxide, like that, you can use any one. So can I remove this carbon with a less electronegative bromine or not? Then I carry carbon with 2 chlorines and 2 electron set. Okay, this combination is most important. It may helps in Riemann-Tiemann reaction, also generation of a carbon, and this is used to trap a double bond present in this one. So this is a well-known reaction which I given in heterocycles. So when chloroformine sodium hydroxide is given, what are the products we'll expect? If this combination is observed here, I would like to remove hydrogen and 1 chlorine. Then which 2 elements are left on carbon? 2 chlorines with carbon. So that carbon is going to be added here. So can I make a formulation? Where you will make a formulation? Where you will make a formulation? Riemann-Tiemann. Second position or third position? So now it is second position or not? So you may take formulation on second position. Okay, and you may expect a one ring expansion reaction. Where you will expect ring expansion? Ring expansion, you will get chlorine here now. This mechanism already given. This is called abnormal RTR. So what is the EPS position of pyrrole? Indole. Third position. So benzobifuran. Benzobifuran. Second position. I say it is exception, try to remember. Benzothiophene. Third position. Pyridine. EPS only I am asking. Pyridine EPS position. Third position. Quinoline. I think they are not there in your mind, I think so. Try to remember EPS and NPS positions. First you write it one place and keep revising every day. Okay? Quinoline, third position, followed by fifth and eighth position. Isoquinoline, same. Fifth and eighth position. Eighth position is dominative as compared to fifth position, and especially neutral medium, acidic medium, 2 different EPS positions are expected. You need to revise, otherwise it will be not there in your mind. Why? Because organic chemistry is a highly evaporating subject. You need to heat it regularly, otherwise it can escape very easily. If you boil continuously, it will be there in your mind. Once if you stop heating, zero. So if you want to read one more time, you need to start from initially. One more time you need to heat continuously. So that's why be careful, try to revise regularly. Now haloform always generates a carbon like this. Okay. Next I am using salt of sulfonyl hydrazine. Salt of sulfonyl hydrazine. So this also includes in coupling reaction. Here nitrogen carry negative charge with a potassium or sodium. So this includes in sulfone. Now this is on thermal decomposition or photochemical decomposition. Thermal or photochemically, this is responsible to give carbon. So carbon with 2 electrons. Next we can also go for photolysis of thermolysis of diazirine. Diazirine. Okay, diazirine is what? See, carbon attaches to nitrogen and a double bond nitrogen. So this is on photolysis. What happens? See, break these two and finally see carbon carry 2 electrons and nitrogen is removed out. This is diazirine reaction. Irene, iridine, 2 points explained. Diazirine, unsaturation is present. Remove this radical forms N2 and this carbon carry 2 electron. Okay, and we can also prepare by using a ylide reaction. Okay, now carbon carry negative charge. Okay, and sulfur carry positive charge. This is called sulfur ylides. Phosphorus ylides Witting reagent, sulfur ylide is present. Negative positive get disappear out. You can write a double bond even. Okay, so this is on photolysis, on thermolysis. This bond will be removed out and see carbon carry 2 electrons. And what is removed out? There is a loss of dimethyl sulfide, DMS. If these reagents are given anywhere, try to generate carbon. So be careful with diazomethane, diazoketone. Okay, then one more is chloroform. This is called haloform test. Haloform test also includes by using this particular combination only. So this combination is important. This is well known. You can, by using these two, you can generate a carbene, but be prepared here. So you write a key point. If more than one electronegative elements are present, more than one electronegative elements, you can remove one hydrogen and one chlorine. If dissimilar electronegative elements are present, try to remove less electronegative halogen. Clear? So in this only see, if I write two hydrogens, two bromines are given. If I add sodium hydroxide, what kind of carbon you may expect? CH2Br2. Can I write one hydrogen and one bromine or not? Always try to remove one hydrogen and one halogen. If CHBr3 is there, we removed one hydrogen and one bromine. So two bromines are left over on carbon. If CHCl3 is there, one hydrogen, one chlorine. Then CCl2. If CH2Br2 is present, remove one hydrogen and one bromine, CHBr is present. So this kind of generations also helps in trapping a unsaturated double bond. This combination is very, very important. CCl4 in sodium hydroxide, CHCl3 in sodium hydroxide, okay, CH2Cl2 in sodium hydroxide, etc. Now third one, stability. So is it carbons are electron deficient or electron rich molecules? So they are electron deficient. So when carbons are given, always remember electron rich or electron releasing groups increases stability of carbon. Okay, electron releasing groups increases stability of carbon. Suppose if I take a carbon with two methyl groups here. Now I am writing a carbon with only one methyl, and if I write a carbon with two hydrogens, which is more stable? So in this example, which is more stable? First one is more stable than second one and third one. Why? Because here two methyls are releasing groups. Here only one methyl is a releasing group. Okay. Suppose if I write a nitrous around carbon. See, this is CH carbon. Now here nitro I written taken two times attaches to carbon. Now I written CH2 with two hydrogens, which is more stable. Third one is more stable than first one and then second one. Indirectly I am saying that donuts increases stability, withdrawing groups decreases stability. Now I am taking a conjugation. Conjugation present over here. Okay. Next, here two conjugations are present. Okay. Later on I am taking a normal hydrocarbon. Now it is a carbon. Carbon also involved in conjugate stability. Carbons also stabilized by conjugation. So can I say second one is more stable than first one and third one? Yes. Here two conjugations, one conjugation, no conjugation. So can I write like this? Benzene carry carbene. Now benzene carry only one carbon and one hydrogen. Then I return CH2 this one. So say the order of stability. Now this is carbene. This is carbene. This is carbene. How it is get stabilized? Say the stability order of carbene. Which is more stable here? First one is more stable than second one and third one. And here second one is more stable than first one followed by third one. Greater the conjugation, greater the stability of carbene. Same concept. Delocalization as well as resonance stability. Now see, here nitrogen connected to carbene and here nitrogen connected to one more carbene. Okay. Now here NH2 connected to carbon. So otherwise you can say OCH3. OCH3 connected to this one. This is CH2. Okay. Here also carbene, carbene. Next, I am writing CH3. Two carbons connected to carbon. Two methyls connected to carbon. Now say which is more stable? First one is more stable than second one, then followed by third one. Remember, it is stabilized by non-bonding electron. It can stabilize by non-bonding electron. It is also stabilized by non-bonding electron. It is only stabilization done by using inductive effect. Now it is mesomeric effect. Now these electrons are donated to empty orbital of carbon. So when carbon carry two electrons, when adjacent if non-bonding electron atom is present, that can donate electrons to empty orbital of carbon. So now this is found to be more stable. Suppose finally we can write like this: when donor attaches to carbon with two electrons. Okay. Next, I am writing a hydroxy. Hydroxy attaches to carbon with two electrons. Next, I am writing benzene attaches to carbon with two electrons. Okay. Next, I am writing double bond attaches to carbon with two electrons. Which is more stable? Which is the most stable carbene? See now, carbene attaches to heteroatom. These carbons are get stabilized by non-bonding electron. Always non-bonding electron stability greater than pi electron stability followed by sigma. So here non-bonding, non-bonding, pi, pi. So can I say first one greater than, second one greater than, third one and fourth one same order. You can apply resonance concept, delocalization concept even for carbene as well as nitrine. Why? Because carbenes, nitrines having empty p orbital, especially this one having empty p orbital, this will be get stabilized here. It is stabilized by conjugation like this. Here also stabilized by pi electrons on benzene, pi electrons on benzene. Here conjugation, here also conjugation. Here only inductive effect. You can operate mesomeric effect as well as inductive effect in case of carbenes. So don't think that it is applicable only for cation, anion. Even it is applicable for carbenes. Over. How to identify carbene? Detection, very easy. Only ring forms. So when any unsaturated molecule added to carbene, that is converted into the form of a ring, that is a detection for a carbene. Okay. Suppose see, if I write a double bond, when double bond added to carbene, when double bond is added to carbene, what happens? See, this olefin and carbene get combined together like this. So this will be added here and this will be added like this. Okay. And finally what happens? What is the final answer? Suppose reaction is proceeding with a carbene intermediate, add one unsaturated molecule, that unsaturated molecule converts into 3-membered ring. So means it is a carbene intermediate. Suppose if I add a triple bond, carbon-carbon triple bond is added. Now this is carbene. So then what is the answer? So can I convert carbon-carbon triple bond into double bond? Cyclopropene intermediate. Okay. Next, see, you can also add a imines. When imines are added to carbene, what happens when imines are added to carbene? So what is your answer? Now can I add like this? This is CH2. Now this is CH2 nitrogen with one nitrogen. Can I write one more carbon? Carbon. What is this? Aziridine. Aziridine. So formation of aziridine by adding a imines is an evidence of formation of a carbene. If reaction is continuously progressing and we have a question in your mind that whether it is a carbene intermediate or not, simply add one imine. If it is converted to aziridine, it becomes a carbene intermediate. Add one double bond, add one triple bond. So regularly you will get a rings or not. So if you are getting rings means definitely carbene is a intermediate in that reaction. Carbon nitrogen triple bond I am adding. What happens when if I add carbon carbon triple bond, you will get a cyclopropane. Right now I am adding carbon nitrogen triple bond. What is the answer? Now can I write carbon nitrogen or not? What is this? Azirine. 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 Now when molecular oxygen reacts with CH2, what happens? When molecular oxygen reacts with carbene, what do you expect? So you will get like this. What is this? Dioxirane. Dioxirane. Suppose if N2 is added, nitrogen triple bond combined with carbene, what is the answer? So you will get nitrogen double bond or not? Nitrogen double bond, finally CH2. What is this? These names are very, very important. That's why first I completed heterocyclic compounds. Diazirine, irene, iridine, irene. First two are unsaturated with nitrogen, without nitrogen. Next two are saturated with nitrogen, without nitrogen. So these are the identification methods. So what is the common thing which you observed here? Formation of a 3-membered ring. See, every time what we are getting? 3-membered ring. So formation of 3-membered ring is a common evidence for trapping a carbene. Don't forget to write 2 electrons on carbene. If you not write, it becomes divalent system which not having 2 electrons. Means you should write either positive charge, otherwise 2 electrons. If you write 2 electrons, then only it becomes a carbene. Okay. So that is up to detection. So in your next class, we will discuss about chemical reactions. Okay. Complete generations, stabilities as well as detections. Generations are most important. Every case, generation as well as chemical reactions are most important. Carbenes undergo cycloaddition reaction. Carbenes undergo insertion reaction. Carbons also undergo rearrangement reaction. So the most important rearrangement reaction is untested as well as Wolff rearrangement. Carbons also undergo Siemens-Smith reaction. Okay, carbons also undergo ring expansion reactions, especially abnormal Riemann-Tiemann reaction. That all applications we will discuss in your next class. Okay, we'll stop here. We'll continue tomorrow. So tomorrow same time 5 to 8:30 evening. Stop here.